Hi, in today's video we're going to solve paper 2 from May-June 2022 exam series. Let's have a look at the first question and we'll have to find the derivative. So for that I'm going to use the quotient rule where u over v derivative would be equal to u derivative v minus v derivative u over v squared. And in that case u is going to be log x and v is x squared. So y derivative is going to be first derivative of natural log is 1 over x times v is x squared minus v derivative 2x times u, which is log x, divided by x to the power 4. Okay, so 1 over x times x squared is going to be just x minus 2x natural log x over x to the power 4. And we can simplify it a little bit by first factorizing the top. I will get x times 1 minus 2 natural log x over x to the power 4. Cross out x and we'll get 1 minus 2 log x over x to the power 3. And also we have to find the value of derivative when x equals to e. So substitute it and we'll get 1 minus 2 natural log e over e cubed. Now, natural log of e is 1, so we'll get 1 minus 2 over e to the power 3, which is minus 1 over e cubed. And that's going to be my answer for this question. Next one, we'll have to draw a sketch. First, we have the modulus function, and the second is going to be just a linear function. So first I'm going to start with the modulus, and I will start by drawing function y equals to 2x minus 9 without the modulus sign. Okay, so this graph is going to intersect the x-axis at 2x minus 9 equals to 0, so x is going to be equal to 4.5. And the y-interception is going to be when x equals to 0, so minus 9. So it looks similar to that, but then what the modulus does is going to reflect the negative values of y. So all in all, we're going to have this graph. Next one is going to be 5x minus 3. That's just another straight line, and it goes through 0 minus 3 and has the x-intercept 0.6. So it kind of looks like this. Okay, next question, we have to solve the equation, and for that we have a standard procedure. I'm going to square both sides. And now I will have to solve this quadratic equation. I will have to collect everything on one side and make the other side equals to 0. So it's 21x squared plus 6x minus 72. Now let's divide by 3 to make it a bit easier. And now I can use the quadratic formula. Minus b plus or minus b squared 4 plus 672 over 14. And now when I take the plus sign, I will get 12 over 7. And if I take it with a negative sign, I'll get minus 2. Now the question is which one we're going to keep. And for that we'll have to look at the graph. We have only one intersection, so that means we're going to have only one solution. And our intersection is to the right of 0. So this is our solution and it's positive. So that means we're going to keep only 12 over 7. Okay, next one, differentiation. So this question is about implicit differentiation. And if you're not sure where to start, I've got another video explaining the concept and what to do. But for now, I'm going to just differentiate both sides of the equation. derivative of 1 is going to be 0. So I'm starting with e to the power of 2x times cosine 2y. And for that, I'm going to use the product rule, which is uv derivative equals to u derivative v plus v derivative u. So derivative of e to the power of 2x is going to be 2e to the power of 2x. Don't forget the chain rule. Times cosine 2y. Derivative of cosine is going to be minus sine 2y. Don't forget the chain rule, so it's times 2 times u, which is e to the power of 2x, and don't forget to multiply by y derivative whenever you're differentiating the term with y. So that also comes from the chain rule. And next derivative of sine y is cosine y. And that equals to 0, and don't forget to multiply by y derivative. Okay, so now I'll have to make y derivative the subject. So first I'm going to move 2e to the power of 2x times cosine 2y to the other side. For the next step, I'm going to factorize and take y derivative out of the bracket, and then I divide by the bracket to get y derivative. Okay, and they're asking for a specific value when x is 0 and y equals to pi over 6. So it means I'm going to substitute 0 and pi over 6. And when I do so, I will get y derivative equals to 2 over square root of 3. Okay, question 4, trapezium rule. And I will actually start with question B because it's going to be easier to explain what I'm going to do in part A. So first we'll have to draw a sketch y equals to natural log x. And it's going to look something similar to this. Now, what is trapezium rule? Basically, we're trying to estimate the value of the integral by splitting our curve into trapeziums, like that. And we're going to try and find the area of each trapezium, instead of actually finding the area under the curve. Now, why is this going to be the underestimate? Because if you look at the graph, there are some gaps between the curve and between each trapezium. I'm just indicating them in red. And that's why it's going to be the underestimate, because we're not accounting for those small red pieces. And I'm going to explain this as trapeziums are under the graph. And next one, I'm going to go back to part A and actually calculate the area of each trapezium using the formula area equals to base 1 plus base 2 over 2 times the height. And in this case, the vertical lines are going to be the area of trapezium. Let's say base 1, base 2, and the height is going to be equal to 1. Okay, so the first trapezium is going to be log 2 plus 0, that's the first base, over 2 times the height, so it's actually a triangle, plus log 3 plus log 2 over 2 times 1 plus the last trapezium, log 3 plus log 4 over 2 times 1 again, and we can bring 1 over 2 out. We'll get log 2 plus log 3 plus log 2 plus again log 3 plus log 4. Then when we have the sum of logs, that means we actually can combine them into 1 by multiplying. Like that. And we get 1 over 2, natural log 1 over 4. Then we can bring the power. So it's 144 to the power of 1 over 2, and the power of 1 over 2 is the square root. So we'll get a natural log of 12. Alright, question 5 is about a factor theorem, which is if x minus a is a factor of p of x, then p of a must be equal to 0. So that means in our case, p of 4 must be equal to 0. I'm going to substitute 4 into our polynomial, and I will get 128 plus 16a minus 16, and that must be equal to 0. And from here we can find a. So that means a equals to minus 7, and our polynomial is going to look like 2x cubed minus 7x squared minus 3x minus 4. Okay, and hence factorize p of x. So that means I will have to divide it by the factor, which is x minus 4. So first of all, look at the biggest power of x in both cases. I will have to multiply x by 2x squared, so I can get 2x cubed. And when I do so, I will get 2x cubed minus 8x squared. Subtract, we'll get x squared minus 3x minus 4. I will have to multiply x by another x, so I can get x squared. And we get x squared minus 4x. Subtract, and we'll get x minus 4. So I have to obviously multiply x minus 4 by 1 to get x minus 4. And subtract, and we got remainder of 0. Now, the question is, can we factorize even further? Now, that depends on the quadratic. If the quadratic equation has solutions, then we can factorize it. If not, it's not factorizable. And to do so, we'll check b squared minus 4ac, which is 1 minus 4ac is going to be 8, so it's less than 0, so not factorizable. That means this is going to be our final answer. Okay, next question. We have to show that equation p of e to the power of 3y equals 0 has only one real solution, and find the solution. Now, so first, let's state p of x again. So that must be equal to 0, and then make a variable change, x equals to e to the power of 3y. So first, we're going to solve for x. Now, the product equals to 0 when either x minus 4 equals to 0 or 2x squared plus x plus 1 equals to 0. And as we've seen before, the quadratic has no solutions because b squared minus 4 ac is less than 0. And then from this equation, we got x equals to 4. And since x equals to e to the power of 3y, then 3y equals to natural log 4. And our solution is going to be a third natural log 4. And that's the only solution. All right, next question is about the integration. We know that the area is 120 squared units. And that basically means that the integral from a to a plus 1 of 3 to the power of e to the power of 2x minus 1 dx equals to 120. So first let's actually integrate, and we'll get 3 times integral of from a to a plus 1 e to the power of 2x minus 1 dx. Keep 3 outside, then integration of e is easy, it's just e to the power of 2x minus 1 itself, and then to compensate for the chain rule, don't forget to divide by 2. And that goes from a to a plus 1. Now let's substitute the upper limit. We'll get 3 over 2 times e to the power of 2a plus 2 minus 1 minus 3 over 2 e to the power of 2a minus 1. Simplify this a little bit. Okay, and the question says that this must be equal to 120. So let's make the equation. Right, I'm going to multiply everything by 2 and divide by 3. So it means times 2 over 3. And I'll get e to the power of 2a plus 1 minus e to the power of 2a minus 1. And that equals to 120 times 2/3. That's 80. Okay, now look at what we are supposed to get. So we're not actually supposed to solve for a, right? We have to show that a equals to this expression on top. And if we look at it carefully, then we'll see that e to the power of 2a minus 1 should be on the right side. And that's exactly what I'm going to do. I'm going to move it to the other side. Okay, now at this point, I will take the natural log of both sides and I will get 2a plus 1 equals to natural log of 80 plus e to the power of 2a minus 1. Now subtract 1 from both sides and then divide by 2. Is it the form they were asking for? Yes, it is. So we're done. Okay, next one is about iterative formula. So first, let's state the formula from the previous question. And it's going to be a n plus 1 equals to half log 80 plus e to the power of 2a(n) minus 1 minus a half. Okay, and before I start solving this equation by iteration, I need to find a good starting point. So first, I will substitute a equals to 0 into both sides of the equation and see the inequality sign between those two. So if I substitute a to the left side, I get 0, and if I substitute a on the right side, I will get 1.67. Now, left side is smaller than the right side. Let's try a equals to 1. 1 on the left side, and then on the right side, we get 1.7. So that means 1 is less than 1.7. So in both cases, we got left side is smaller than the right side. That means our solution is not in between 0 and 1. How about a equals to 2? On the left side, we got 2, and on the right side, when I substitute it, I'll get 1.8. So now the left side of the equation is bigger than the right side. That means the solution is somewhere in between 1 and 2. Okay, so now I can choose any number in between 1 and 2 to be my first an. And I will choose this to be 1.7. Now, if I substitute 1.7 into the iterative formula, I will get 1.7556. Now, this becomes the new n. an. And it gives us, again, when I substitute into the formula, 1.7626. And I have to continue this process a little bit. Now, all my calculations are given correct to 5 significant figures, but the question says find the value of a correct to only 3 significant figures. If we look at the last 2 values of a n plus 1, we see that they are the same, correct to 3 significant figures. And our answer is going to be 1.76. Okay, next question about integration. And when we have to find the area in between two curves, we'll have to find the integral of the top one minus the bottom. So that means we're looking for the integral from 0 to pi of 2 pi minus 2x to the power of 1 over 2 minus the bottom curve, sine squared x and all of these dx. Okay, to start with, we'll have to split it into two integrals, and let's start with the first one. Integral from 0 to pi of 2 pi minus 2x to the power of 1 over 2 dx. That's going to be 2 pi minus 2x, add 1 to the power, 3 over 2, divide by the new power, so divided by 3 over 2, that means times the reciprocal, 2/3. And then to compensate for the chain rule, divide by the number next to x, which is minus 2. And that should be from 0 to pi. Okay, let's simplify this. And when we substitute pi into there, we get 2 pi minus 2 pi on top, so it's 0. Substitute 0, and we'll get plus 2 pi to the power of 3 over 2 over 3. So all in all, we got 2 pi to the power of 3 over 2 over 3. Okay, next integral. From 0 to pi of sine squared x dx. So that's not a standard integral that you can find in MF19, and we have a standard technique for that. If you got a trigonometry of some sort squared, for integration, just replace it with a double angle formula. And for that one, I'm going to use cosine 2x equals to 1 minus 2 sine squared x. We can rearrange it to find sine squared. And it's 1 minus cosine 2x over 2. Now, substitute it instead of sine squared. We get 1 minus cosine 2x divided by 2 dx. It is always a good idea to bring the constant out of the integral, which is 1 over 2. And now it's easy to integrate. We'll get x minus sine 2x over 2. And that's from 0 to pi. Let's substitute the upper limit. We get a half pi, and then if I substitute 0, I'll get 0. So all in all, that's pi over 2. And now let's combine those two together and get the final answer. 2 pi to the power of 3 over 2 over 3 minus pi over 2. Okay, next question, trigonometry, and I will start by replacing sine 2 theta with 2 sine theta cosine theta. And secant theta is going to be 1 over cosine theta. The next one, we can expand cosine of theta minus 30 using the combined angle. That's cosine theta cos 30 plus sine theta sine 30. Okay, now let's simplify a little bit. Cosine cancels out. 3 times 2 is 6. Expand the brackets. Okay, and let's substitute cosine 30 and sine 30. We get 6 sine theta plus 10 square root of 3 over 2 cosine theta plus 5 sine theta. Okay, and then all together, it's going to be 11 sine theta plus 5 square root of 3 cosine theta. And now we have to make it back into the compound angle in form of sine theta plus alpha. Now, before we do that, we'll have to factorize, and this technique is a bit tricky, but we'll have to bring out a square root of a squared plus b squared first, where a and b are the numbers next to sine and cosine. So the square root of 11 squared plus 5 root 3 squared is going to be 14. So we'll get 14 and then 11 over 14 sine theta plus 5 square root of 3 over 14 cosine theta. Now look at the formula, and we are supposed to get the answer in the form sine theta plus alpha. And if we expand it back, it's going to be sine theta cosine alpha plus cosine theta sine alpha. Now in those brackets, we already have sine and cosine of theta, and the number attached to sine must be cosine alpha. And then likewise, the number attached to cosine theta should be sine alpha. So we can find alpha by doing the inverse cosine of 11 over 4, for example. That gives us 38.21 degrees. Now let's substitute everything back and we'll get 14 times sine of theta plus 38.21 degree. That's the answer for the question. Okay, in the last question, we have to use our identity to solve the equation. And to do so, we can just spot that this time theta equals to 2 beta. And we can rewrite our equation using the identity. So it's 14 sine 2 beta plus 38.21, and that must be equals to 2. So first we can divide by 14. One over 7, then take the inverse sine, and we'll get 2 beta plus 38.21 equals to 8.21. And whenever you're solving equation with a sine, right after taking the inverse sine, do 180 minus the first value. So it's 171.79. That's 180 minus 8.21. Okay, now subtract 38.21 from both, and we'll get 2 beta equals to minus 30. And beta must be between 0 and 90, so that's not the case. And from the second equation, if I try to find beta, I will get beta equals to 66.8 degrees. And that's in a range from 0 to 90, so let's leave this as the answer. Okay, and that was the last question of this paper. I hope that was useful, and I will see you next time. Bye-bye.